The term computer bug was born from literal bug that was found by hardware engineers in early computers. Nowadays bugs have become digital, and our goal as software engineers is to produce high-quality, bug-free code, which in reality is quite hard to achieve. The main challenge comes from constant changes, when we are introducing new features, doing change requests or fixing anything. And you never know when this little pesky bug will get in your code and how long it will live. That's why automation testing has become our first line of defense, verifying that our code behaves as expected and remains functional as it evolves. But here's the catch, now we have to maintain two of the code bases. One is the production code, the actual business logic, and the test logic, to verify our business logic. But who verifies the tests? If your entire test suite is always green, how can you be confident that when things start to break, that there will be a test to detect it? Well, code coverage could help. It provides plenty of insights of which lines were executed, which parts are missed. But we all have seen this number being high, but in reality, not covering anything. And that's why I want to introduce you to mutation testing. While the goal of testing is to detect when things break, the goal of mutation testing is to break things on purpose and see if you can detect it. This is done by creating so-called mutants, an altered version of your code, introducing small bugs. Then entire test suite is executed against each of them, and if any test fails, mutant is killed. But if he survives, he should become your #1 target, because this change is undetectable. For example, let's look at this discount calculator. To achieve 100% code coverage, we just need to cover 3 branches. One, when user is premium. Second one is when spending is above this threshold. And third one, when spending is below the threshold. So what is the problem? We have covered every branch. Well, let's introduce 3 mutants. The first one will negate the premium condition. The second one will change the premium discount from 20% to 0. And third one will alter the threshold of spending, for example, to 1100. Now running this test, we can see that mutant number 3 survives, which basically means that I can alter the discount threshold without anyone noticing it. Okay, now let's see how we can automate it and see it in action. So here is the same example. We have some logic to calculate a discount for a customer. So we return 20% if the customer is premium, we return 10% if it is above the spending threshold, and if the spending is quite low, we return just a 0. And we have a test that will return a 100% coverage on our code. So we have a test case for each of the branching. So for the premium one, for the one that is high spender, and the one that is regular customer. And running this test with coverage, we can see that we get 100% coverage. And from the example you saw, if I will modify this boundary condition, I will create this mutant and rerun the tests, there will be no single test that will detect this mutant. And of course, doing it manually isn't practical, so we would like to have some sort of way how we can automate it. And one of such libraries is PIT, Mutation Testing Framework for Java. And installing it is as easy as just adding the dependencies. So for Maven, it's enough to add a plugin. So let's add it to our POM file. In the plugin section, I will paste the latest version of this plugin. If you're using JUnit 5, as you probably should be, there is one additional dependency needed to support it, which is called ptest JUnit 5 plugin. Now that we have added it, let's at least once run all of the test suite to generate all the target and test classes. Now, either through terminal or just a Maven viewer, we can execute pytest mutation coverage plugin. Just looking at the output, we can see that there were multiple mutants created. They were sent to the classes to test. Mutants are created with different mutation strategies called mutators. In this case, there is one survived mutant with conditional boundary mutator. So it looks like the same example that we have just looked. We can see there also were 2 different, like primitive return mutators. So return value has been modified, and those were killed. Another mutator was negation on the condition as well. There were 2 killed mutants and 0 survivors. There also are some timings because some of the mutants can go into the infinite loop, and there should be a timeout to detect it and kill the mutant. So we can see there is also some statistics like line coverage, how many mutants were generated, how many mutants got killed, how many mutants were with 0 coverage, what is your test strength. You can use it as a code coverage metric if you want. And of course, besides outputting in console, it also has generated an HTML report, which can allow us to look in the results more interactive way. So in the target, we can see pit reports, there is index.html, and we can now open it in browser and see it or embed it in better view. Here we can see pretty much the same information. So there was number of classes, the line coverage, mutating coverage, that there was 1 mutant still alive, and the test strength. Let's go deeper into the file itself, and here is the line. So here were 2 mutants created. One was the conditional boundary that survived, so it's meaning that we have changed that value of total spent, and there was also a negated condition, which was killed. As well, we can see the coverage and other mutants that has been created, and we can see they all were successfully killed. For example, the first negated condition on line 6, so this is the premium condition. The 7th line return the 0, so the same way we have altered the discount of the customer. You can see in this report what were the active mutators. And of course you can add or remove based on the relevance for your codebase. Now let's strengthen our test. I know that the problem was in the boundary condition. Basically, I have not defined it. I have tested some values in the interval below it, interval after it, but I have not tested exact one. So let's introduce 2 additional. So what will happen if I put a boundary itself 1000 and it is not a premium user, and what would be our expectation? So our expectation would be that it is below our threshold. So the result is 0. And another one that I'm interested in is when I will go over the threshold. So I'm still not a premium user, then I expect a 10% case. Let's quickly run and verify that those tests actually pass. We can see they are green, and let's rerun our mutation coverage. And now we can see that there were 5 generated mutants and 5 of them got killed. So let's see again the report, and we can see now that everything is green. So what does it mean? We have all green lines. Is it the same way? Is it the same thing as code coverage? Well, no. It means that each of these mutants, each of these modifications got stopped by a test. So if someone does an intentional change or accidental change, there is a test to catch it. So this is mutation testing in action. And for today, let's keep it light. So let's not dig into deep configuration part like having different mutators or running it only on changed code. Let's stop it here, and I actually would encourage you to explore it on your own. Execute it on your codebase. There is a saying among developers that the only useful test is the one that fails. Well, it's quite debatable, but mutation testing does bring this principle into action. While mutation testing is quite a powerful tool, there are some considerations that you need to take when adapting in your development flow. One is execution time. Mutation testing can be slow, especially on large code bases. The amount of mutants that can be created is quite high. While many libraries support parallel execution because this problem can be parallelized, it is often not recommended to include mutation testing in your continuous delivery pipeline, rather performing periodical testings, for example weekly, nightly, monthly. Another important case is irrelevant mutants. Not all surviving mutants will indicate a real problem. Some mutants can create unrealistic scenario, modify, debugging or logging code, so each of these mutants should be evaluated inside of your context. Sometimes it even may be useful to disable some of the mutators if you see that there are constant false positives produced by it. Another recommendation is to focus on the new code after doing the initial tests. So now you run mutation testing only on the files affected. And of course, general, keep tests fast. Mutation tests will benefit from it as your team. While having its own downsides, the mutation testing is still a very good tool to increase quality of your tests. By challenging your tests with the idea that if I will break this, will someone detect it, will just increase the confidence in your test suite. The next time you see a comfortable green test suite results, remember those tests are as good as their ability to turn red when things go wrong. So if you enjoyed such content, leave a like, leave a comment, subscribe so you don't miss the next one. And until then, keep coding, and I see you next time.